Yeah. So today's topic is about QuickML and its platform capabilities. So in software development, we have a tool for every layer of the stack. The same is true for AI as well. Building and serving one AI feature in production today means managing model training, environments, test and production infrastructure, handling compute and hosting, a separate LLM API provider, a vector database for retrieval, and the orchestration layer, trying it all together. Each layer adds a maintenance overhead and another point of failure. So that's a problem Catalyst QuickML solves right now. QuickML is the unified platform that brings custom ML model training, LLM serving, RAG, all under the same roof with a single set of APIs. Our goal is to let everyone build on the latest AI capabilities without the dependency for coding or AI expertise as a prerequisite. Build faster, easier, integrate easier, and ship without overhead. So let me show you exactly what the stack looks like today and what it looks like with QuickML. So the AI stack today is fragmented. So the data preparation, model training, model serving, LLM access, RAG, etc. Each layer has its own tool and its own vendor and its own integration overhead. QuickML brings all of these under one platform. Train and deploy custom ML models without managing infrastructure. Integrate large language models directly into your workflows. Access RAG and knowledge-based capabilities into your business systems. One platform, one set of APIs, and build as per usage, which are easy to track as per business point of view as well. So QuickML is mainly built for businesses that need advanced AI capabilities without the complexity, and for development teams who want control over what they build without stitching together multiple different tools to ship one feature alone. So that being said about QuickML, let's look at what we are covering today. So today's agenda is to explore QuickML capabilities. The first is to build a customer segmentation model using credit card service providers' raw data and deploy the model in production. And the second is you'll see how to tune the LLMs using its parameters and access them via our QuickML console. So third is we will use a sample organization level data uh, to demo a RAG system and see how it responds for relevant queries. Usually it would respond with the context along with the organization data. So by the end, you'll know how exactly what makes QuickML unique and where does it stand in your AI development stack. So let's get a quick glance of QuickML offerings. So data is the most important resource in building, training any machine learning model and build any AI feature from scratch. So QuickML is equipped with various data connectors to upload into the console, data into the console from various Zoho apps, as you can see in the slide, and cloud data storages, and even file uploads. We are also adding more data connectors as and when required. So you could let us know if any of the data source is not available here, we'll work it out. Once a dataset is imported, you can start building pipelines to train the respective models. As you can see here in QuickML, various type of custom ML models can be trained using the standard drag and drop pipeline builder, which we'll see in the upcoming demo. Each of these models shown here, like prediction, text analytics, recommendation, clustering, etc., all of these are equipped with a dedicated set of their ML operations, necessary algorithms as per the pipeline. So machine learning expertise, and we also offer AutoML as well for a few of the models. So machine learning expertise and no coding knowledge is not required while building a pipeline. So we have a help documentation to understand what each operation does, and you should just use drag and drop them into the pipeline builder and save it and execute it. So it will train the model and generate respective information like model evaluation metrics, visualizations, etc. in the console itself. So along with the custom model building, QuickML also offers generative AI capabilities. It hosts large language models that are suitable for various use cases. As you can see here, we have an instruct model, coder, and vision language models, etc. And along with we have a RAG system as well, which it will respond with the ground truth. So it is designed in a way that users can use it intuitively just from the browser interface itself. So no framework setup, no infra configurations or test environment setup is required. So we'll cover these in this session as the demos. So on every model you build and configure in QuickML, like custom model building, LLM or RAG, you get a dedicated REST endpoint for deployment. Same authentication pattern across all the three different type of APIs here. OAuth scopes, post method, headers, etc. All are consistent, regardless of what's the model and what's offering underneath. So your integration code does not need to change whether you are calling any model endpoint or RAG endpoint. So the endpoint API is what your application calls in production environments. So this is the QuickML overview of the platform. So let's build our first customer segmentation model. So before that, let's understand small news about small information about clustering. So clustering is an unsupervised machine learning technique, which means that there are no predefined labels or categories in the data itself. So you do not tell the model what the groups are. You give the data to the model, and it will find its natural groupings on its own. So it groups the similar records with same characteristics together by the algorithm itself during the training process. So to put it simply, what comes out is segmentation of customers or records based on the actual behavior, like customers who spend similarly, repay repay similarly, or borrow similarly. So they are grouped it together. Businesses use this to understand who their customer segments are really are and target them with better offerings. So this will help in the conversions as well. So we are going to build a customer segmentation model from scratch and deploy it and publish to the production in few minutes itself. So let's look at our use case and the data first. So for the sake of demo, we are taking mock data of credit card service providers, customer interaction data. So credit card companies offer a wide range of products and various features. For now, we'll take credit card utilization data of customers that includes reward points, installment purchase plans, cash advances, and credit limits, etc. All that. So, but matching the right offer feature to the right customer is hard without knowing how the customers actually behave. So our data set for this demo has around 9,000 customers with 17 features like purchase volumes, installment patterns, cash advance frequency, balance utilization, and repayment behavior. So no labels, no predefined classifications are available in the data set, just the raw transaction history. So we will look at the data in a minute. So we're going to let the clustering algorithm find the natural groupings that are already exist in the data and train the segmentation model and deploy it live in API. So let's go over the step-by-step process for building the pipeline. So first step is to upload data. Using one of our data connectors, we'll upload the data into the console, then create a clustering pipeline and build it with the necessary data and machine learning operations, and select a suitable clustering algorithm for this case. Selecting the right algorithm can make the model perform better. So finish the and then finishing the pipeline configuration and execute it. Upon successful execution, a model will be generated. Now we evaluate the model using the evaluation metrics and standard visualizations that are generated, which we will see in the model details page. And the last step is to create an endpoint and deploy it in the production environments. So let's go to the console and start building it. So I'll open the console and we'll share the screen. So I hope the screen is visible.
Yes, Gautam, it's visible.
So if you open the Catalyst console .zoho.in, you will be getting into this create project page. where you will just create new project and you can start give the name and you will start working on it. So let's build sorry, one second. So let's start building a model or project. So you will land into this QuickML landing page. Here we will start exploring what QuickML is, and we'll start importing the data set. So this is a home page, and here we'll go to the data set. We can see the multiple data sources that are listed in the earlier slides. So let me upload the data set that was provided to you. So after uploading, it will generate the profile dataset profile on its own, so that it's easy to perform the data analysis and find out what are the operations that could be done. And here we will see we have the missing values here, and you will see the correlation heat map here, where it will understand the relationship between the two columns, which are two features, and the visualizations where we can generate multiple visualizations that are required. And this is a sample preview of our data set. You can view the features that are available in the data set, which we talked about, the purchases, the credit limits, and purchase frequencies and all that. So now the data set is uploaded. Let's start creating a pipeline, clustering pipeline to be precise. So we'll go create, and we'll create pipeline here. So here you can see the multiple pipelines, right? So we'll select the clustering pipeline, and we will choose our data set that we uploaded. Clustering model, the name is, and create the pipeline. So now we landed onto the pipeline builder here, specifically for clustering. So here on the left panel, you will be able to see the list of operations that are provided for data pre-processing, data cleaning, extraction, and various ML operations as well, along with the algorithms that are specifically equipped for clustering pipeline. So now we will start to build a pipeline now. So I'll just drag and drop a few columns and connect it together. So this fill columns, I'm using it to address those missing values that we saw earlier in the dataset. So there I'll just show the select the decimal and select the column that has missing values, and select what needs to be provided to fill the missing value here. So I providing it with mean values. So and click on like save the configuration here. And then I will use a few other configurations as well. Select or drop. So I'm removing the unnecessary columns that are required in the pipeline building. Save. And then we will use normalization operation to normalize data. If you can see here, observe in the preview, we connect columns, and I will save it. So as you can see here in the preview section, so whatever the operations that are being saved and applied, you can see the live application of that configuration here. So let's say I drop the column here, so you can see there is no the dropping will be applicable here, and normalization also being done as a preview for you. So now we have the data set data preparation ready, and now we have to choose our clustering algorithm to finish the pipeline. So in our case, we'll use k-means model, k-means algorithm for our clustering model. So we have already predefined default parameters here. So for every algorithm, the default parameters are being provided. So we just have to change the values and fine tune according to the business needs. So now the pipeline is built, and the next step is to execute the pipeline so that it will generate the model, our required clustering machine learning model. So I'll just click on execute. So now the pipeline execution has started. So in the interest of time, I'll just show what were the model that is already built, and so that we don't want to waste any time. So now once the pipeline is built, you will be having a view like this. All the pipeline configurations are successfully executed. So now we'll go to the model. The result is the model that we got. So the model contains evaluation metrics here of this clustering model with Silhouette score or Helsinki Harbera score and Davis Bolden score, where it will be used to evaluate the performance, the model training performance, and how if it is not up to the mark, you can just click on edit and go to the builder and retrain model with a few more configurations. And there are model visualizations you can see here in the clustering distribution chart. So it will give more information on how the clusters are formed and the distribution of the clusters in these two charts. We also QuickML also provides the model predictions. So in our case, the agenda is to segment the records into different clusters. So that all the clusters which has similar characteristics will be in same cluster. So our model output is assigning the clusters for each record here. So as you can see, that information is also being provided here, so that it can be downloaded and useful for further analysis on analysis of each customer segment. And QuickML also provides a versioning as well, as you can see down below here. So there are many versions. If you create like multiple versions, all the versions are listed here, which is useful for tracking and ML ops as well. So now we have built the clustering model. So the next step is to build an endpoint and serve this model in the production, so that businesses can access the model. So for that, we'll just have to create an endpoint. So we'll go to the create button here at the bottom. Create endpoint and choose. I'll be choosing our clustering model, and we'll give some clustering. Clustering model as an endpoint name too. So let's create an endpoint. So now we landed onto the endpoint details page here. So what you can see, you'll see here is the test the model section, where we will provide the sample data here, and you will just try the result. What it essentially does is, it is taking the input with these values, and it is feeding it into the model, and the model is generating a response that was shown here. So in this case, for this record values, it belongs to the cluster 0. That's what this result is about. So now we have the model endpoint ready. So now we will have to publish the model to get the API details. So click on publish, and then you will get the endpoint API URLs and the OAuth scopes, HTTP method, and headers required with the sample data format, request data and sample response data, so that it will be easy for you to integrate this model into the business systems. So that is about the clustering model. So let's go back to the presentation again. So now so that is the first demo in our session. I hope it is clear, and you have the data for you to try that on. And so coming to the next part of the section, we just built a clustering model and publish the model via endpoint. Now we go for the second part of the demo on the same platform, but different capability. This is generative AI capabilities. Past few years, AI in production meant building and deploying your own custom models. That is still true, and QuickML still does that. but the landscape has changed. The large language models rewrote what is possible. Teams now need to serve large language models and ground them with their own data and integrate both into their products without setting up a separate infrastructure and separate setup for each of the custom model or generative AI features. So QuickML stands forefront in adapting to these changing needs. Hence, generative AI capabilities are brought inside the same platform. Distinct APIs, same flow, same deployment model you use for clustering. So let's go to the building blocks of our generative AI in QuickML platform. So the first one is LLM serving. LLM is a large language model that works as a brain. QuickML hosts a catalog of LLMs and VLMs with configurable parameters and ready to call APIs. Second one is RAG, retrieval augmented generation, where it acts as a bridge between your own data and LLM. And third is knowledge base, where it acts as data repository for ground truth for the models to access your data. So QuickML ships them as one connected ecosystem. So let's have a quick walkthrough of LLM serving in QuickML. So as I mentioned in the earlier slides, QuickML hosts LLMs and VLMs for the users to quickly access and serve the large language models via API without having to manage any infrastructure separately. So it is equipped with models like that supports various use cases like instruct model for general purpose tasks and coder for development cases and reasoning model for multi-step problems and VLM vision language model for image related tasks. So QuickML also provides flexibility to tune these LLMs with parameters that can alter the response structure and format as a result. So a separate test interface setup is designed with adjustable parameters just to test various probable combinations suitable for your use case in the QuickML console itself. So once you are satisfied with the responses, you can use the same configuration for deploying the LLM in your business systems with dedicated API details for each of the model. We are actively pushing the ease of integration as a priority while upgrading the features. So let's take a quick look at LLM serving module in QuickML. So I'll just share the console just to give overview. Okay. Is the I hope the screen is visible.
Yes, Gautam, it's visible.
Yeah. Okay. So this is the LLM serving that we are offering from QuickML under generative AI section. As you can see here, LLM serving RAG and knowledge base. So we'll just look at the LLM serving for now. So here you can see the language models that are hosted in QuickML. If you click on it, we can see the API details with necessary information and headers information and auth scope authentication, and a few other JavaScripts for easy integration as well, and a sample request response. These are the model details. And the sample request response is the model details here. So let's go to the chat interface. So in chat, you can see here in the chat interface, I typed a few questions and it just I typed few questions and it generated few answers. So I did it after changing few parameters here. If you can see in the right panel, there are parameter section where you can just adjust the values of each parameter and try out different questions and see how model is responding. With these ones, if you are satisfied enough for your use case, then you can just use those parameter values along with this API information. So as in the sample request format here as shown, and you can access the same model via LLM serving. So we have multiple models, right? As I mentioned, for vision language, will take input of the image as well, and GLM Flash, it's like a mixture of experts model, better for reasoning capabilities, which we can utilize it. Yeah. So that's the okay. So that's the LLM serving that we have in QuickML console. You can just go ahead and try it and give it a try and see how it's working out for you for your use case. So for our customers that use our generative AI features, we have these few cases that I want to explain it in a simpler manner. The first one is the document data extraction. The customers will send an image or a scan document to the VLM model, and VLM reads that input and extracts the information from the image document and provide it as a structured data as a JSON response. That's one of the case. And the second customer implemented as a customer support classifier model. The use case is that it will follow sequence of steps. So whenever a ticket registered by the end user or customer, LLM analyzes the intent, urgency, and classify the ticket into a relevant category. And after that, it will draft a first relevant reply to the user. So that's one entire sequence of the use case. And the other one is like code review assistant, where you use the coder model capabilities is to analyze the code and catch bugs and styling issues or code issues, anything that were found out maybe after missing the test cases before each release. So these were the cases that are implemented from our customers. So this is in regards to the LM serving in QuickML. So now we understand how to configure LLMs as per our needs and serve them in production. So LLMs are powerful, but they don't just only know the data. They only know the data that you are just trained on. So ask a query about your internal policies or documents or last quarter's data about your company. So LLM will be like prone to hallucination. So you'll get either a confident wrong answer, or in the best case, there is no answer at all. So the RAG system fixes this by retrieving the relevant context from your own knowledge base data. So it feeds the retrieved chunks of the uh, data from on the query that you provided to the model, and it generates a response that is contextual enough, keeping the uh, input data in mind. So we don't have to retrain or fine tune the entire model again. So it comes in handy when your business requires the latest information accessible to your employees, users, customers, like all the time. So we know that the data information will get updated day by day. So RAG will help us to help employees to help customers to keep updated about what's going on. So let's see how it works in QuickML console. So as you can see here, the first step is to upload your data into the knowledge base and add the relevant docs to the document store in RAG in QuickML. So once the data is uploaded, you can start querying in the RAG interface itself in QuickML. So what you should be getting is that specific and contextual answers generated by the model by keeping the query and retrieved chunks of information from your documents as an overall context. So in QuickML, you will also get citations of retrieved chunks of data in the response as well. So it is useful for traceability requirements necessary for auditing purposes. So now we focus on how we implement RAG in businesses to improve their response systems. Instead of an abstract use case, so let me take a sample organization as a reference and show you how it works directly. So this is the third part of the third demo for our session. So we are taking a Helio Systems. It's a fictional SaaS company. So we have three of their internal policy documents. One is HR policy, IT security policy, and travel and expense policy documents. So we are going to upload these documents to the knowledge base and build a RAG system using them and ask questions to see how RAG is answering to them. So let's go to the console again and start working out. I'll share a screen in a minute. Yeah, I hope screen is visible. So we are in the second module under generative AI section here, the RAG, retrieved augmented generation. So what it necessarily is that it should generate responses accurately, keeping your own data as a context. So for that, the first step is to upload documents in knowledge base. So uh, we have three documents: HR policy, IT security policy, travel expense policy, already uploaded. Uh, for you can upload by clicking here, and you can use a different upload file or via Zoho OneDrive or Zoho Learn into the knowledge base. So now it is uploaded. All right. So we'll go to the RAG interface. Try retrieve augmented generation, and now you can see the RAG interface. I believe. Right. So here on the right side, you can see there is a document store. So this is like a document repository for your RAG session here. So for one session, you have to upload whatever the required documents into the document store from knowledge base. So this is knowledge base documents available in knowledge base. So we'll just have to select whatever the required documents into the document store and just click on add. So it will add the all the documents here required for this RAG session. So and I have a model, instruct model as our brain, RAG brain LLM, and here you can see the API details of RAG. So where similarly we have a same all the details as I mentioned earlier, the API details, auth scope, authentication, HTTP headers, and the request response formats for this QuickML instruct model. So now what I'll be doing is, since I have uploaded these three documents, I have a set of questionnaire prepared for these for understanding what RAG is and how it works. So I have a simple set of questions. This is the expected answer, and let's see whether RAG is responding as accurately or not. So just before that, once you upload data into the document store, so QuickML will take care of the generating a vector database and by handling the chunking process. So what it necessarily does is it will chunk the entire data, these three data sets, into chunks of information and store it in a vector database. It is entirely handled in the backend itself, so that users doesn't have to worry about like how it is working in the backend and chunking process. So now let's try to understand how RAG is working. So for the first question, the parental leave policy at Helio Systems, it should tell that like 16 weeks full paid leave for primary caregivers and all that. Like it is asking what's a parental leave policy for a primary caregiver. So it should show and mention that 16 weeks of a full paid leave. So let's go to the RAG interface and try it out. So I just copied and pasted here. So as you can see here, the primary caregivers at Helio Systems are entitled to like 16 weeks of fully paid work. So it is like as expected answer here. And if you see the response breakdown, so these are the documents that it read to answer this query. For this prompt, it retrieved the information from the HR policy document and the travel expense policy document. While it may not be accurately retrieving the information, like it may retrieve the majority of the information, but it will answer for your query as accurately as possible. So now let's go for the second another question, where what's the maximum allowed hotel rate for tier 1 city like New York. The answer is like 350 documents as per in the documents. So let's go and see how the RAG gives the answer or not. Yeah, so now we got the exact response of the hotel rate. So now let's try another different case. Like let's see the notice period of a senior engineer resigning from the company, like how much it shows. So it shows that 45 days notice period, and let's go check it out in the document, in the HR policy document here, whether it's correct or not. Down. Yeah. So now in the HR policies document, if you go down here, the notice period for senior contributors, it is 45 days notice period. So its RAG is answering correctly as expected. So now let's change it to 60 days and save it, and let's see how now upload the same document to the RAG session and see whether RAG will respond the 60 days for the same question or not. So let's download the document. Let's create a duplicate session. I'll remove the HR policy document and I'll upload the downloaded one which we updated just now from 45 to 60 days. So I'll just open, upload. So now we have the latest HR policy in knowledge base. So now let's again follow the same steps. Go to the RAG and add these documents to the document store. So now we'll wait for a few seconds to handle the chunking process at the back end. So meanwhile, I'll just take the question. So this is a question that we need the latest answer now, since data is changed. So now let's go ahead and try it out. So now you can see it answers correctly with the updated information, like 60 days notice, and the response also will include the same information, right? So yeah, so to be precisely saying it, that whatever the latest information that you uploaded in the documents, the RAG will find out the information from the document and it will just respond. So you can just directly integrate that RAG using our API with the latest information. So let's go to the slide here. So that's it about the RAG as well. So we now finished all the three demo sessions, and we went through a quick walkthrough of segmentation. We built a segmentation model using clustering pipeline using our credit card service providers data, and we served an LLM. We know how we showed APIs of how to serve LLM in production environments, and we grounded LLM with your organization data using the RAG setup where we just witnessed. So these are three different problems and three different APIs, and in single platform, in one platform. So it has the same authentication across all three services, same API header, same API information, and we do have the same support team for all of these services that we have provided in QuickML. And the same support team is also responsible for implementing your use cases. So that is the overall overview of what QuickML is. So let's go through the cost details now. So QuickML has two simple meters for cost tracking with pay for only what you use policy. Like custom models like clustering, classification, regression, all of the custom ML models are built as per a number of API calls that are being consumed. So it scales directly along with your usage. And generative AI feature like LLMs and RAG usage is built on cost per million tokens consumed, with separate input and output tokens, separate build and input and output tokens built as per usage. The same price whether you are calling the LLM directly or you are calling LLM via RAG. So same price applicable. So reach out to us for your use case or expected usage, and our solutions team is ready to assist you in building all the AI solutions that are required for your business. So we have a set of planned upgrades of the generative AI section, and also we have planned upgrades for the entire QuickML as well, to be specifically pointing out generative AI section here, where we'll have tool calling options where LLM acts by invoking through the external APIs to get more context instead of just relying on the training data. So it's like foundation of agents, where it is agents will does the autonomous tasks based on the tools available. And we also planning to provide these RAG types, which helps for hybrid searching and re-ranking or answering with higher precision, and the conversation modes like stateless and stateful at the same endpoint, and agentic mode as well for multi-step reasoning nodes. These are the just few of the enhancements that were planned. So many are in the pipeline as well. So that's all about the QuickML and its pricing structure here. So please do log in to the QuickML console and explore the interface, and start building your first model. Since the data is already provided, it's easy to try it out.
Okay, so I think we've covered pretty much all the questions. So thank you so much for everyone for joining us today. We hope this webinar is insightful to you all, and we're very much looking forward to see you all in an upcoming webinar. So just a reminder that this session is being recorded, and we will send you this session in email, and we will also post this in our social handles like YouTube and LinkedIn. Please keep an eye on that also. Thank you everyone for joining. Thank you Gautam for all the wonderful demos and clear explanations. Thank you very much.